Simple and fractional distillation. Distillation is a technique used to separate two substances based on the difference in boiling point. Here we have our simple distillation setup where we have our mixture. In this experiment it was a mixture of ethanol and water. We heated it. Due to the difference in boiling point, ethanol evaporizes first. It then travels up the system into the water jacket condenser, where a cooled environment is set up by the water that travels in and out of the condenser. This allows for the vapor to condense into a liquid form, and the liquid is collected. This is going to yield a more concentrated percent of ethanol than what we originally started with. Here we have our fractional distillation setup, which is pretty much the same. However, we have a fractional column, which allows us to have a more efficient separation of the two substances, and we'll go into detail later on in the presentation. Like I mentioned before, in this experiment, distillation was performed in order to separate ethanol from water. Ethanol is a clear liquid. It is flammable, has a boiling point of 78 degrees Celsius. Ethanol is used for fuel, for rockets and cars. It's usually mixed with gasoline. The upside to this is that it can be produced through fermentation. However, you get less miles to the gallon. But the upside is that it burns cleaner. It emits less fumes than regular gasoline, which is good for the environment. It is also used for antiseptics, in disinfecting wipes and hand sanitizers, which kill bacteria, viruses, and help create a cleaner environment. It is also the main ingredient in alcoholic drinks, in beer, wine, whiskey, vodka, and tequila. The difference between simple and fractional distillation is the fractionating column, which we have here, and it's absent over here. What this little addition to the distillation system allows for a more efficient separation of the substances, as I would explain in the next slide. Here we have an animation of fractional distillation. We have our mixture here. It's heated, it evaporizes, it passes through the fractionating column, it reaches the top, it proceeds to the condenser, where it recondenses, and the liquid is then collected in a graduated cylinder. What happens in fractional distillation is that as both substances begin to evaporize, they recondense in these glass beads right here, or they're also known as theoretical plates. As they recondense, and the system gets hotter, they evaporize again. And the one that's going to evaporize first is going to be the one with the lower boiling point, which in our case was ethanol. At the end, we're left with the pure sample of ethanol, which then reaches the condenser, the final condensing stage. It condenses and collected. This yields a higher concentration of our substance. For every half of ml of distillate collected, the temperature of the vapor was taken. Here we have a graph of our fractional distillation and a graph of our simple distillation. From this graph, we were able to tell the percent of ethanol that we initially had, and we're able to do that because at a certain point we are able to tell from the graph that we are no longer distilling ethanol. We begin distilling alcohol. For both graphs, we see that ethanol is it's vaporizing at around its boiling point, which is 78. And however, at a certain point, the graph increases. This increases because ethanol is no longer present, and we are distilling water. So that our graph showed that it was 11 mils of ethanol that was distilled from 20 milliliters of mixture. This makes a mixture 55% ethanol. Possible errors were poor technique. For example, a faulty distillation setup. We could have had a joint that was not properly connected, where our vapor would have escaped. If something like this were to happen, that means that our ethanol would have escaped, and it would not have been collected. This would have gave us a lower percentage in alcohol. The experiment could have been improved in a way where we could have gotten a higher percentage of ethanol yield. We could have done this by manipulating our heat instead of just heating the mixture at random. We could, for example, we could have heated it at 78, 79, 80 degrees Celsius, where only the ethanol would have evaporized and water would have stayed behind. This could have improved our overall accuracy. As we see, simple and fractional distillation are essentially the same thing. They only differ in the fractionating column, which allows for multiple distillation processes, which ultimately yield a higher concentrated or a higher separation of substances. We were successful in distilling ethanol from water through fractional and simple distillation. Ethanol is commonly used in fuel, alcoholic drinks, and disinfectants. As both experiments were done, we've seen that fractional distillation is more efficient in separating the mixtures. Through our experiment, we were able to determine that our original ethanol percent was 55%. Cause for error could have been a faulty distillation setup where ethanol could have leaked out and we could have not collected it. A way that we could have improved this experiment was by manipulating the heat applied, which would have allowed us to separate the mixtures more efficiently.